Hello and welcome back. In this video we'll cover the material in homework 2, which is on sets and Venn diagrams. So a set is a fundamental mathematical object, and the best definition I can give is it's just a collection of things. This will seem a little bit vague, but this is one of the most fundamental things in mathematics. So the definition is at a place where we've almost run out of words to describe everything in mathematics, and this is the only definition that we can give. So I kind of like to think of a set as a bucket, and it could have some things in it, So these things are called members, and I think what's best to do is just to give lots of examples of things that could be sets. So for instance, we can have the set that contains 1, 2, and 3. So we can imagine we've got a big bucket and it's got the numbers 1, 2, and 3 in it. This is a set. The way that we write this down is we use curly brackets, and we'll go 1, 2, and 3. There are other ways to write down sets, but this way we've just listed everything in the set, and we know that this is a set because we have the curly brackets on either side. Sets could have a little bit more difficult description. So for instance, here we could have the set that contains all the numbers from 10 to 20 that are multiples of 3. So now we have to work out, okay, which numbers are going to be in the set and which numbers aren't. So let's write down all the numbers from 10 to 20. 11, 12, 13, 14, 15, 16, 17, 18, 19, and I ran out of space, 20. And now we only want the ones that are multiples of 3. So the question is 10 a multiple of 3? Well, 3, 6, 9, 12. No, we skipped 10, we skipped 11. 12 is a multiple of 3. If we add 3 again, so 3, 6, 9, 12, 15. Oh, so that's a multiple of 3. 18, that'll be a multiple of 3. 21, 21 is already too big. So 13, that's not in there. 14 is not in there. 16 is not in there. 17, 19, 20, none of them are in there. Our set is just going to have the numbers 12, 15, and 18. So both of these sets have three members, but there is a set that contains no members, and there's different terminology for this. But we can just write down a set with an empty list in the middle. There are no members. This is a very, very specific set. It comes up every once in a while, and in mathematics, we just have to be aware that this set exists. It is still a set, but it's kind of empty. It doesn't have any members. And then let's do another example where we have to sort of figure out what sorts of things are in the set. So here we'll have a set that contains all the numbers from 1 to 20 that are multiples of 7. So again, we could write down all the numbers between 1 and 20, and then cross off the ones that aren't in our set. Or we could think about this maybe in a slightly different way. Let's write down all the multiples of 7 that we know. So we've got 7, 14, 21, 28, but we're only looking for the numbers between 1 and 20, right? Well, 7 is between 1 and 20, 14 is between 1 and 20, 21 is already too big, 28 will be too big, any bigger multiples are also too big. So this set will have 7 and 14 in it, and nothing else. So sets can have lots of different things. Most of the sets that we'll be talking about will have things like numbers or shapes, things that are related to mathematics. One way to visualize sets is using Venn diagrams. And Venn diagrams are essentially picture representations of sets. So for instance, I could have a set, so here's one that's not necessarily math related. I can have a set of all the members of the Beatles. So we've got John and Paul and George and Ringo. We're all musicians in the Beatles. So our set will have those 4 things in it. If I wanted to write this down in set notation, I would write John, Paul, George, and Ringo. But it kind of allows us to do a little bit more if we draw this picture. So just this circle here. So let me give an example of some of the things that we can do with Venn diagrams. So let's say that I have two sets. I'll call them A and B. And A is going to be all the things that have doors, and B is just going to be all the things that have wheels. It would be impossible to write down a list of everything that has doors or everything that has wheels on it. But we can draw some pictures to help sort of clarify, what these sets look like. So here we'll have the set everything with doors. So this could include, say, houses have doors, cars have doors. Like doll houses. There's lots of things with doors on them, and a few of those things have wheels, and a few don't. So, for instance, cars would have doors, and they would have wheels. So, our sets are going to overlap a little bit. But, for instance, motorcycles have wheels but don't have doors. So, things like houses and then motorcycles. Houses don't necessarily have wheels. Cars have both. Motorcycles only have wheels and no doors. And then there are things that don't have doors or wheels. For instance, people don't generally have doors or wheels. So we might fit outside of these bubbles. So when we're talking about Venn diagrams, we can look at the things that are contained in one of the circles or that are outside of those circles. So here we can have the things that are only in A, not in B. Here we have the things that are both in A and B. Here we have the things that are in B but not in A. And outside of this, we have the things that aren't in A or in B. And there's different sorts of ways that these sets can be oriented. So for instance, if here I have the set that contains all eagles, and D is the set that contains all birds, well, all eagles are birds, but there are birds that aren't eagles. So how would this look? So again, if I have the set of all eagles, every single eagle is also a bird. But there happen to be birds that aren't eagles. So for instance, in here we'll have all of our eagles. But out here, maybe we have storks. A stork is a bird, but it's certainly not an eagle. So it will live out here, inside of the set of all birds, but it's not an eagle. So maybe we'd have things like ravens and all sorts of other birds would live inside the set of all birds, but not quite within the set of eagles. So we can have sets that overlap a little bit, but not entirely. We could have a set be entirely contained in another, or we can have something like this. We could be looking at squares and triangles. So squares have 4 sides, triangles have 3 sides, so these sets aren't going to overlap at all. No square is a triangle, and no triangle is a square. So when I draw these sets, here's a set of all squares, here's a set of all triangles, they don't overlap at all. There's nothing that we can find that's in both of them at the same time. So, no overlap. And this is just a brief introduction to Venn diagrams and how they overlap. The last thing that we'll do is we can start to label Venn diagrams with how many members are going to be in each area. So if I look at an example here, this Venn diagram is going to come from a class at MSU Northern, and what I've done is I've labeled, okay, so there are a few business majors in this class, and there were a few football players in this class, and I've tried to label each area in here. So for instance, inside of the set A, so out of all the business majors, there were 10 that were only in A, so there were 10 business majors that were outside of the set of football players. In here, we can see where they overlap. That's the number 3. So that means that there are 3 students in this class that were both business majors and football players. So let's try to interpret these numbers and figure out some answers to some questions. So how many students were both business majors and football players? So we come up to our Venn diagram, and we see that A is going to be all the business majors, and B is going to be all the football players. So if we're looking for things that are both business majors and football players, those are going to be the people that are in both of the sets at the same time. That's going to be 3. There are 3 members of the overlap. And so there are 3 members of the set A, and there are 3 members of the set B that are in both. Okay, so the next question is, okay, how many students were football players? So football players is everyone in set B. And we have 2 numbers in here. So the question is, what are we going to do with these 2 numbers? Well, 3 corresponds to the number of football players that are also business majors. So those are the ones that overlap. And 6 corresponds to those students that are just in the set B but not in A. So there are 6 students that are football players but aren't business majors. So they're in the set B but they're not in the set A. So total, we had 3 students that are both football players and business majors. Another 6 students that are football players but not business majors. So total, there were 9 football players in this class. Next up, okay, so how many people were not business majors? Okay, so when we look at our diagram, we see four numbers. 10 would correspond to how many people are business majors but not football players. 3 is how many students were both business majors and football players. So the 10 and the 3, these are the students that we don't want because we want the ones that aren't business majors. So over here, B, this 6 here is going to be those students who are football players but are not business majors. So there are 6 of those students. And then we have this 11 hanging out down below. What does the 11 mean? Well, the 11 isn't in A or B. So the 11 are going to be those students that aren't business majors and aren't football players. So overall, there's going to be 11 people that don't belong to either set, but those 11 people are especially not business majors. Okay, so the 6 people that aren't business majors but are football players, and the 11 people that aren't business majors and aren't football players, would mean that there's a total of 17 students that aren't in either. And then this last question down here, how many students were in the class in total? So how big was the class itself? So all I need to do is just count how many students are in the entire class. And here, we just need to count all the students. So all 10 students that were business majors but not football players, all 3 students that were both, the 6 students that were football players but not business majors, and the 11 students that weren't business majors or football players. So that's 10 plus another 3 plus another 6 plus another 11, and that should give us 30 students. Cool. So this is just a brief introduction to Venn diagrams, which represent sets. And these sets can be sets of people, sets of numbers, sets of shapes, and sets are very, very important